Okay, I think we can get started. Nice to have you all here again for the community meetup and then the Notus edition. So this edition is going to be 3 parts. And the first part, I will briefly introduce you to UltraFeedback and how we curated it and how it eventually led us to a high quality curated data set that we eventually used for training Notus. Then the second part, Gabri will give a brief overview of how we trained Notus, actually using the alignment handbook from Hugging Face. And then at the end, we have a guest performance from one of our community members that actually created a cool PDF viewer within Argilla UI, and also a table editor within the Argilla UI. And it's nice to see that, the community is quite active and also maintaining these kind of things outside of the Argilla repository as a good maintained fork. And that's actually Jonny Tran, and he will be able to show what he worked on. And he hopefully will also be able to actually integrate that within Argilla after a while. As a remark, we are recording this session, and also in the bottom right corner, there's a thing where you can actually start chatting with each other, and there's also an ability to ask questions, do Q&A, and that will help us guide us through some of the questions you might have during the session. I will start with sharing my screen. So for this session, I actually created a notebook, and I will share the notebook as well with you guys, just to highlight the steps that we've gone through. So for the UltraFeedback data set that was actually curated, we really highly used the alignment handbook from Hugging Face and also the OpenBMB UltraFeedback data set. And that's actually how we eventually came to the Notus model that we've trained and shared with all of you. And this wouldn't have been possible without them, but we actually focus on what we are good at, data curation, and actually ensuring that the data that we use is of the highest quality. So a brief introduction about the UltraFeedback dataset is actually a dataset where the instruction dataset for preference tuning of large language models, where the instructions were pulled from a set of different datasets throughout the large language model space, like the UltraChat dataset, ShareGPT, and FLAN. And these instructions were randomly sampled. And then eventually there were different models that were used to generate responses to these sampled instructions. And all of these responses have then been annotated or added suggestions by the GPT-4 according to 4 preference annotation schemas: the instruction following annotation schema, truthfulness annotation schema, honesty, and helpfulness. And these were given as preference annotations with a score, and also with your rationale on top of that. And additionally, besides that, there is also a general overall score that was obtained from GPT-4 and a critique score that was obtained from GPT-4. So what we actually did is we installed Argilla and loaded and installed the dataset library. Then what we can do is actually load the UltraFeedback dataset that was used by Zephyr, the model trained by Hugging Face based on the UltraFeedback dataset. And this dataset contains a prompt ID, a chosen data from the dataset pair, and a rejected example from the dataset pair. And that kind of looks like this, where this is one of these sampled instructions from the previous datasets introduced. And then eventually you have this, one of these contents that were actually accepted as one of these data entries within the preference dataset that was obtained from the UltraFeedback dataset. What we can then do is go through, once again, go through the initialization method of Argilla. What you can do is really easily initialize and install Argilla using the Hugging Face Spaces integration that we have, where you would go to this Hugging Face Space quick start image, and then press deploy on Hugging Face Spaces. And here what you can do is create the test UltraFeedback, for example, and select the Docker image, the Docker template, and some space hardware. We will not be setting this specific configuration variables because we want to use the defaults just to showcase and keep it simple. Then we can create a space, and what Hugging Face is doing for you in the background is actually building this space and configuring everything that we need for Argilla, so the UI, the server, and also Elasticsearch as a backend to do semantic search and these kind of things. So while we are waiting for the space, I've actually used a space that Danny created for me before the meeting. And we can actually access the space and access the Argilla instance by connecting via an API URL, which we actually can obtain from the space that's being created in the background, and also an API key. In this case, it's the default configuration that I mentioned before, and that's just admin.api key. Whenever you use one of these spaces, you can actually configure this to be more safe, so to say. But for now, we'll just use the defaults. Then after that, what we do for Argilla and also for this use case is that we actually want to configure a dataset based on the assumptions that we have about that dataset. In this case, we are configuring our preference dataset. So what we want is to get an overview of the prompt, the chosen response, and the rejected response, as we might see in the UltraFeedback overview. And what we've done is actually enabled Markdown so that we can also see the code snippets properly rendered within each one of these responses. You can also not enable Markdown, but then they might be rendered as rough code, and that becomes less readable. Then for the rating question, this is actually the score that's obtained from the UltraFeedback dataset, and this will eventually be used also to annotate and evaluate the dataset. But for now, we will just fill it with the UltraFeedback dataset responses that were actually used for training the Zephyr model from Hugging Face. Then on top of that, we'll actually add this metadata property to be able to filter on the overall score that was used within the preference overview. Then we will be pushing the dataset to Argilla, or whenever the dataset's already present, actually load the dataset from Argilla. What you can actually see is that this dataset was created within the Hugging Face space, and there's a dataset ID as well. After that, what we can do is actually add these records from the original UltraFeedback dataset to Argilla. So what we will be doing is looping to the initial dataset that we got here. So the dataset that was used from Argilla. And we will actually be mapping that to an Argilla dataset where we create feedback records, where we add the prompt to the prompt field, the chosen response to the chosen response field, the rejected response to the rejected response field. And we do some small transformation to actually include the chosen scores, the chosen overall scores as suggestion to each one of the questions that we define for Argilla. Then we will append the records and actually add the records to the Argilla dataset. And if we actually open the dataset, what we can see is that there's here one of these examples with this overview. So this is what that might look like. Then what we saw is that we can open our dataset. And when we actually go through all of these responses, what we can do is actually filter and sort based on the overall score chosen that we've added and obtained from the UltraFeedback dataset that was used by the Zephyr model that was trained on the UltraFeedback dataset by the Hugging Face team. And when we actually go into that dataset, is that we can then filter sort based on the score chosen, based on the overall score chosen. And the overall score chosen is actually provided by ChatGPT, by GPT-4, to assess whether the chosen response was correct. And as you can see here, according to the UltraFeedback dataset used by Hugging Face to train the Zephyr model, the score chosen is 10. But when looking at the prompt and the chosen and rejected pair, I would say that this chosen example isn't 10 per se. And if you actually go through more of these examples, what you can see is also one of the simpler ones. There's a definition, then we expect an output based on this conversation, for example. And what you can see here is that the output yes was chosen, but given the initial description of the task that we're handling here is a conversation, I would have expected this one to be performing better. And yeah, if you actually go through the first couple of hundred or thousand of these examples that were actually used to train the model, you can see that there's a lot of these things that don't really make sense. So this kind of got us to think, okay, there's something going wrong here, and there's something weird within the UltraFeedback dataset. And that's actually when we started skimming through some of the code that were used for generating the UltraFeedback dataset. And we spotted a bug where very low scores were multiplied by 10. And then instead of having a 1 score, that a 10 score would be assigned to each one of these records. And that's actually a bug that we found within the GitHub page here, and that you can actually see here. And that's actually what led to all of these weird preference data examples within the preference data set. So every example that was completely wrong, in a sense, automatically got assigned a completely right rating, as in a 10. And this was used within the UltraFeedback dataset, and eventually also within the dataset that was used to train Zephyr by the Hugging Face people. So we actually reported this bug as well, and we instead started to generate a new preference data set using the average ratings of the overall scores instead of the average rating of the preference scores instead of the overall score provided by GPT-4. So what the preference scores are these individual scores that were given by GPT-4 to either instruction following, truthfulness, honesty, or helpfulness. And the overall score that was initially used and that was wrongly computed in the UltraFeedback dataset was the overall score that was provided as an overall overview of how the instruction performed, the response performed for the instruction. And what we did is grab each of the individual scores of these and just average them out for the dataset, where we also assume that each of one of these individual scores might be a bit more specific and a bit more higher quality based on the fact that it only covers one of these facets. And that's how we actually came up with the new UltraFeedback dataset that we use for training Notus. There's a post-processing notebook also attached to this collab, which you can skim through it and see how we compute these things based on the original dataset. But to get an overview, what we did was take the average of each one of these scores. And then on top of that, we actually removed some of the examples to improve the dataset quality as well. So what we did is didn't include the truthful QA instructions to ensure that we didn't include the training data, evaluation training data also in the training data set, because for these a lot of these benchmarks, this is actually also used to evaluate the performance of models. On top of that, not all scores, not all of the responses did contain a preference, all of the preference criteria. So some only contained less than 4 of these 4 examples above. So the only a score within the dataset was assigned, for example, the instruction following. So we also didn't include those. Then for some of the examples, there weren't enough generated responses either. So we also filtered those out. And eventually some of the records resulted in average scores with ties to one another. So we also didn't include these. And that's actually what you can see here as well. So eventually out of the 64,000 original samples, we only included 61,000 of the samples used to train Notus. And then lastly, there were some potential next steps that we might find interesting to have a deeper look at. So potentially we could use something like a sentiment classifier as shown below to assess the quality or the sentiment of the rationale behind the general generated response of GPT-4 or the critique on the output of the model. We could also filter based on score differences between the chosen rejected pair, where we might give preference over examples with a very high score difference for the chosen pair and the rejected pair. And this is actually one of the things that we've already included in our distilabel package for generating synthetic data sets for preference data generation for AI alignment. And eventually what we could also do is maybe compute average weighted scores with different preferences with helpfulness, honesty, or helpfulness to evaluate to improve. And there's also a thing that you can do to improve general performance of the model, improve the model performance, or see whether one of these metrics may be more aligned with what humans find important in model performance. And that's how we did the data pre-processing, the data cleaning, and how we can use Argilla to do these kind of things. And you can go quite crazy in terms of the metadata, in terms of the assumptions that you make, in terms of the suggestions that you provide to your Argilla dataset. And that's really up to you to make these assumptions and look into how we might solve these kind of things. I'm not sure if there are questions, but otherwise I will give the stage to Gabby to kind of highlight how we actually trained the model and how we might use it.
Thank you, David. Yeah, so I'll briefly explain how we fine-tune Notus. I'll be brief because, the most important thing that we did for the fine-tune was the data preprocessing and creating this new version of UltraFeedback dataset, as David has explained. And basically for the fine-tune, what we did is to reuse the resources that the Hugging Face team released for the fine-tune of Zephyr. They created this repository called the Alignment Handbook, in which they share several configurations for fine-tuning a model, like using basically Hugging Face transformers, Accelerate, and the integration of Accelerate with Deep Speed, which is a framework from Microsoft to distribute the training and inference of a model. And let me share what we basically did for the fine-tune. We created this repository called Notus, in which we uploaded all the configurations used for the training and all the scripts. And it is important to say that Zephyr had two phases for the training. It has in the first phase, what they did is a supervised fine-tuning, which yield this model, Zephyr 7 billion supervised fine-tuning full. And then they did a second TPO phase, in which the model generated was basically Zephyr 7 billion beta. And as we discovered that UltraFeedback had this problem with the score, we created the new dataset, and we decided to replicate the second phase, the DPO fine-tune, using our new dataset, which is this one, the one that David showed before. And and about the hyperparameters, we didn't tweak nothing, to be honest. We just reused the default configuration in the Alignment Handbook. And I think that the only thing that we changed was using class attention too for the training. And also we tweak the batch size, because the guys from Hugging Face, they use 800 of 80 gigabytes. And at that time, we only were able to get 800 of 40 gigabytes. So we had to tweak a bit those parameters to fit the model and make the train possible. And I think that's the only thing that we changed. And the most important step was the curation of the UltraFeedback dataset. And and we executed the DPO find, and we got those 7 billion B1, which achieved better score in Alpaca Eval than Zephyr, and roughly the same score in the NT-Bench benchmark. We are very happy with this experiment and with what we have achieved. And we will continue iterating on this model, because we have some other stuff that we want to test, as curating completely the UltraFeedback dataset for using the critic score instead of the preference scores. And that's it. And now I want to show how you can use Notus, or just chat with it if you want. Here in Hugging Face, in the Argilla profile, we created this collection in which we put all the resources related with Notus, and we created this space, Notus chat. So you can come here with you just need to be logged in Hugging Face, and you can chat with Notus. So for example, we can ask it to translate the black cat to French. Just give me the translation. And it will take a bit, but not too much. Or maybe it will take a bit more. Okay. And it told me this example in specific. It should have returned only the chat node. And I was using this example specifically because we realized that with our fine-tune, Notus was better at instruction following than Zephyr, but it decided to troll me. Okay. And okay, this is the the first option that you have to try Notus. The second option, if you want to use it, I don't know, in one of your projects, what you can do is to create an inference endpoint. For that, you have to come here to Hugging Face, and then solution, inference endpoints. And here you can click new and just select Notus 7 billion B1. And yeah, you can change the region and also select the GPU that you want to use. Basically, you can leave the default configuration and it will work out of the box quite well. I already created one here for the demo, and this is the one that the chat UI is using. And in this notebook that I created, I can show you how to use the inference endpoint. Basically, you just have to install Hugging Face Hub and log in, because yeah, if the endpoint created is protected, then you have to log in. Then we get the inference endpoints, providing the name and the namespace. And then here what we are doing is building the prompt for Notus. It used the same prompt format as Zephyr, in which we provide the system prompt and then the user message. And yeah, and then we just put here assistant, so the model knows that it has to generate this. And okay, let's see if this time it doesn't troll me. And as you can see here, we have written the same prompt as in the chat UI. Translate the black cat to French, returns the translation only, and it returns just the translation, the chat noir, sorry. And okay, other option to load Notus is to use transformer. For that, yeah, we need to install transformers, also accelerate, and bits and bytes. At least if you want to load it from a Google Colab using the free GPU, which in this case is the NVIDIA T4. But yeah, you need to install accelerate and bits and byte, because we need to load it in 8-bit, because otherwise it won't fit in the GPU. Yeah, we import the auto model for causal LM, and we use the device map auto, so accelerate knows how to, or where it has to load the model, in this case the GPU. And we indicate that we want to load it in 8-bit, so it fits. Then we load the tokenizer, and in this case, we are going to use this new feature of transformers, which is the apply chat template. And yeah, basically we have a list in which each element is a message in a conversation between the user and the assistant. The first message, we are defining the system prompt. Here, I told it that it is a helpful AI assistant that follows instructions. And yeah, I'm telling it again to translate the black cat to French. And yeah, we apply the chat template, and here is the prompt that we are going to send to the model. You are a helpful AI assistant that follows instructions, translate blah 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 to French. Okay, and yeah, we call the generate method with the tokenized chat, and yeah, if it gives us the new IDs that has been generated, and we use the decode method again to decode the IDs. And as you can see here, assistant le chat noir, and yeah, again it added some stuff, but I think that if we tweak a bit the system prompt, it will follow the instruction and won't give us this. And yeah, okay, and finally I want to showcase how to use Notus with distilabel, which is the new package that we have released from Argilla to create synthetic dataset using LLMs. So yeah, it is quite easy to use. We are going to install distilabel, and in this case, we are going to use Notus to generate instruction for math topics as in the last community meetup. So basically, distilabel has 3 main components, which are for components, sorry, I like, which are the task, which is the one that defines the behavior of the LLM. In this case, we are going to use the self-instruct task because we want to generate instructions from a list of topics. Then we have the LLM, which will use the task, and it's basically we can call it like an engine because we have LLMs that you can load in your computer, but you can also interact with another LLMs via APIs like the OpenAI and the inference endpoints. So in this case, we are going to use the inference endpoints LLM. Finally, we are going to create a pipeline which basically orchestrates the whole generation process. Okay, so we are going to create the self-instruct task. And in this case, we are telling the LLM that its purpose is to generate instruction about mathematics, and that it basically knows a lot about maths and logic and reasoning puzzles. Okay, and then we create the inference endpoints LLM, and we are telling it the name and the namespace, and we are also telling it to use 8 threads to execute several requests in parallel, and we are providing a temperature of 0.7, and we are finally telling it to just generate at the 500 new tokens. Okay, and finally, we create the pipeline using the generator LLM that we have created here. And we create a Hugging Face dataset to include the math topics from which new instruction has to be created. It's important to know that the main data structure that distilabel uses a Hugging Face dataset. That's why I'm creating here a dataset. And then finally, we call the generate method of the pipeline, passing the dataset, and we are telling it that for each row here in the dataset, we want 5 new generations, and yeah. So what we get at the end when this finish is a new Hugging Face dataset, as you can see here, that has 5 columns input. In this case is the math topic. Then the name of the model that we have used to generate the instructions, Notus. And finally, we have a column called generations, which contains the new instructions that we have generated. Let's take the first row, and as you can see here, for the first math topic, which was algebraic expressions, it has generated a list of instructions. What is the standard form of the expression? And it has created all these instructions. And that's it for me today. Also, if you want to use Notus, I show how to use it with transformer and inference endpoints, but you can also load it using llama CPP because the blog basically quantizes the model weights and transform it also to the format that llama CPP expects. And you can also load it using VLLM. And I think that's it for me today. I think that now David will continue, and Jonny too.
Yeah, perfect.
So
Thank you, Gabi. Can you share the notebook, the collab as well with everyone?
Sure.
And so we once again highlighted how you might use LLMs for within distilabel, and this is also how we can feedback to the UltraFeedback dataset. So this dataset was mostly synthetically generated, and that's also a thing that you can achieve with the distilabel package that we've recently introduced. So ideally, what you would be able to do is combine different instruction tasks, different prompts, and different LLMs to go from having no data at all to having this synthetically generated data set that would be similar to UltraFeedback, for example, which you then can use yourself to fine-tune LLMs from. And that's what we strive for in terms of making this publicly available for everyone as well. And then I would like to give the stage to Jonny, who's going to maybe give a brief introduction about his work and who he is, and then showcase some cool things that he has been maintaining in a fork of Argilla. So feel free to take the stage, Jonny. Thank you for being here.
Yeah, really awesome work that I just saw. Can't wait to try it out. So I'm Johnny. I am working as a scientist in a lab, and in science there are a lot of research papers that have tables and data that are like locked in PDFs and they're not in any database. I'm actually using Argilla as the front end UI for people to use LLMs and extract the data and review the data from those PDFs. Let me share my screen. So previously you had a markdown render table, and you might have a problem with very wide table or very long tables. And if you wanted to edit markdown as a table on the text field, it can be a little unwieldy. I use a tabulator, like an open source table renderer, and put it on top of the text field. Yeah, that's what it looks like. You can have validation. You can have in the column, say this is like categorical. You can have some interactive component within this component here. And for the editing part, you can copy this since it is just a JSON encoded string. If the here recognizes that it's a proper JSON table, it would try to render the table. And you can have some interactions. You can type on here, for example. Yeah, so you can write like almost everything, and it can update quite well and add row, add column, and so on. So it's pretty robust, pretty easy to existing code. And I think it serves a pretty good purpose of adding more interactivity in this component, because it doesn't really connect to the other questions here, but I added this interactivity between different tables, so you can set up like one of those event handler things. Okay, and then for the PDF one, so since we're extracting data from PDF, I've added this button here where it would load PDF, the backend, so it goes through the API and then load it from the database. And it's referenced through the metadata of this record. Yeah, and that's it.
Thank you. That's cool to see. And it's also one of the features that I've been eyeing for a while. So I hope this will really help us for going through the development process quicker. And yeah, I hope you will also be able to help us in terms of the development and get some of your feedback throughout that process. And for one of the things that we've been wanting to add, given that it's relatively easy according to you, is also the table question, so to say, where we might be able to, instead of render these really difficult editable markdown tables, and then just use this integration. So one of the issues that was assigned that I created a while back was actually the feature request for adding this table. So I was really happy to actually see this combine. And really thank you for the demo and the showcase. And I'm sure we will stay in touch as well.
Yeah, sounds great. Happy to share.
Yeah, would be great. And if anyone's maintaining a fork by themselves with cool features, feel free to reach out. And also if anyone else wants to present, also feel free to send an email or give a request. A question for Louis. What does it take to make Notus available in Ollama? I've been using Ollama for a while for like several demo projects, and it's like a cool thing. And I think internally for Ollama, you need to create probably a reference between the thing that we've showed before, that Hugging Face is doing out of the box, the chat template application. But I'm not entirely sure how we can do that, but it's an interesting thing. And I think we have got this GitHub repository, so it might be a nice feature that we can define there if you want.
I think it uses Llama CPP, right? Or Llama?
Ollama. Yeah, I believe it's quicker, so I'm not sure. At least when I tested it side by side using Ollama, just deployed via brew install Ollama brew serve Mistral, for example. It was way quicker than Llama CPP, but I'm not entirely sure.
Okay. Yeah, I think it should be pretty easy. So yeah, we will have a look because yeah, Llama is cool.
Yeah, I'm not sure either how to do it, but I think if Notus were to go up there on that page, I think that would be a great advertisement for you guys.
Yeah, thanks.
I think
That's a really good suggestion.
Mistral is there, and like some other models are there.
Yeah, so also if you have any feature requests or these kind of things, also feel free to post them there. But I think we will have a look at this to actually ensure that it's more available in different places. Any other questions? Remarks, comments? Okay, then I would like to thank everyone for coming again and hope to see you during the next community meetup just after Christmas, I guess. And thank you for your attendance.
Thank you. Bye. Nice job, guys.
Well, thanks to Jonny as well.
Yeah. Awesome work.
Hope to see you soon.
Yeah, thanks. Bye.
See you.
Thank you. Bye.